Now I'd like to introduce the McGraw-Hill Senior Marketing Manager for STEM, Michael Comer. Michael has been with McGraw-Hill for over 8 years. He's an expert on the Common Core as it impacts math in grades K through 5. And he works closely with our editors and our professional development staff to make sure that the math programs we create meet the needs of teachers and students across the country. Michael is also an author and a former elementary and middle school teacher. Michael, I'm going to turn this over to you now.
Thank you, Alla. I appreciate that, and welcome everyone. I am Michael Comer, as she said, and welcome to the Teaching the Common Core Standards for Mathematical Practice, sponsored by McGraw-Hill. This series of workshops will focus on strategies teachers can utilize daily through their instructional delivery as they work with their students in the class. As we begin to look at the outline of Common Core State Standards, I want to point out that you're all probably familiar with them. They're a research-based set of mathematics standards, and that these standards are closely aligned to college and career expectations for the 21st century. They promote rigorous content with a focus on computational fluency in the early grades and instilling higher order thinking skills in students as they progress across the grades as they mature as learners. The Common Core State Standards include two different types of standards. There are content standards, as you are familiar, and then there are the practice standards. The standards for content are organized by grade level for K-8 and concept in high school, for example, algebra, functions, and geometry. There are 8 standards of mathematical practice, and these span across all grade levels. These were based on the process standards from NCTM and include the strands of mathematical proficiency from the National Research Council. The mathematical practice standards are intended to be interwoven with the content standards. If the content standards are the what of the curriculum, then the mathematical process standards are the how and the why. This series of workshops will focus on the standards for mathematical practice, especially as they apply to the K-8 classroom. And what I'm going to do now is open up a poll, and just to find out from our audience, get a little familiar as to where you are and what grade levels you cover. So going to open up a poll, and I'm going to ask you to identify where you're from, whether it's the Northeast Mid-Atlantic, the Southeast South, the Midwest, Central, the West Mountain, or someplace else. So take a minute, just check off where you're from. All right, I see we're getting up there. All right, great. Let me just share where we are. It looks like we have a representation from across the country. We appreciate that, with the majority of you being from the Southeast South and most of you from the Northeast and the Mid-Atlantic. The second question I'm going to ask is, what grade level do you cover? Are you an elementary teacher, a middle school teacher, high school, math supervisor, specialist, or other? Oh, great. The majority of you I see are from the elementary grades, with a portion of you being math supervisors or identifying yourself as math coaches. Well, what we're going to find today is this workshop objectives are that there are 3 primary objectives of this workshop series. One is to become a little more familiar with the Common Core State Standards for Mathematical Practice. 2 is that we wish to explore ways in which you can incorporate those practices into your daily lessons. And the 3rd is to take a brief look at how McGraw-Hill MyMath incorporates those standards into their daily lessons. So as we begin, let's think for a minute, what are the mathematical practices? They may be thought of as the goal or the outcome that students will achieve as they strive forward in their classroom work. It is what we might refer to as the habits of mind that students have. It is a way of thinking and doing that percolates through their minds as they work to solve problems in the classroom. not only in mathematics, but also in the broader sense of problem solving. It includes areas of thinking, reading, writing, and speaking mathematically, and involves the use of logic and reasoning when approaching problems. It includes using a degree of precision in the details of solving problems and working on calculations. It involves the attending to the detail of mathematics, while at the same time keeping the bigger picture in mind as to the purpose for the exercise. It also includes students using the ability to be flexible in their selection of their strategy, allowing students to evaluate a problem and pick a strategy that they feel works best for them, but then also to be able to change strategies if the student finds that they run into difficulties or are having problems. These are, as I said, the habits of mind, and they should be embedded in classroom instruction at all levels. They describe the kind of teaching and learning that's to be fostered in the classroom, and they truly provide an environment for opportunities for the mathematical tasks that occur, and they should vary in their difficulty, context, and type. So the bigger question is we find ourselves asking is, how do I teach these mathematical practices? Well, the first thing to remember is that the practices are not a checklist of items of discrete skills that are going to be taught and mastered one at a time, but they are really a collective result of creating in students a sense of positive attitudes and a positive disposition towards learning and applying mathematics in their everyday lives. It can be accomplished in some of the following ways: by incorporating problem-solving routines that are embedded in ongoing classroom instruction. It can occur by fostering in classrooms a culture that encourages both discourse and discussion. And three, it can be through providing an environment where opportunities of mathematical tasks, as I said, vary in difficulty, context, and complexity. In other words, it's not done in a 15-minute block of learning or in some small group activity, but the mathematical practices are fostered by the teacher who models a constructive approach to out-loud thinking and who nurtures in their students the process of visually and verbally solving problems so that students can see and hear and understand their thinking as they unlock or decode problems and work towards finding solutions. But before we start, let's look at some examples as to these mathematical practices. We've organized the 8 mathematical practices into 4 workshop series. And as we look at the practice standards, there are some inherent relationships among them that allow them to be organized in a way that they might make a little bit more sense. First are standards 2 and 3, reason abstractly and quantitatively, and construct viable arguments and critique the reasoning of others. These are the skills that students must have in order to think and communicate mathematically and to be able to evaluate the reasoning of others. We've identified that series as the communication skills. There are also standards 4 and 5 that we're going to address, and these are what I refer to as the mechanics of mathematics. That is, they are working with models and tools that are going to be useful to help them solve problems. They are the abilities that students must develop in order to make good decisions about which resources to choose or what methods they select in order to make their calculations more efficient. Standards 7 and 8 are grouped together because they represent more critical thinking areas. They are the higher order thinking skills, where students must develop these skills in order to go beyond the simple computation and to really understand how math works and to become more effective and efficient in their application of the key mathematical concepts. In other words, these 2 standards really work to address helping students to become more adept at their problem solving. And finally, standards 1 and 6 are really what I refer to as the mathematical habits. These are the skills that students need to learn early and use regularly in order to be successful. Certainly as successful as they apply them to learning skills and as they navigate the challenges of real-world problem situations. Today, we're going to look at the mathematical mechanics, Standard 4 and 5, modeling with mathematics and using appropriate tools strategically. So what does that mean? Well, Standard 4 addresses the importance of using models and physical objects to understand and explain problems. It is important to keep in mind that the models are more than using physical manipulatives to demonstrate thinking, that mathematically proficient students can draw pictures, make diagrams, use charts and tables in order to convey what they are thinking and to use them as examples as they explain their thinking. As students mature, they should be able to use different models to solve the same problem and be able to describe why one model may be better than another or more suited than another, which leads us to Standard 5, using and selecting tools strategically. Standard 5 deals with the importance of students being able to understand which tools are helpful in solving certain problems and which are not. And as students begin to become familiar with models to describe their thinking, they'll begin to recognize which tools are more versatile or suitable to certain types of problems. So it's easy if you want to think of modeling as being something that's used to solve a problem, whereas tools are things like calculators, manipulatives, or number lines that help students solve the problem. Models are the way that the problem is solved and explained. I'm going to preface this webinar by saying we're going to use several examples of problems as a way of talking about and delivering the concept of models. And because of the nature of the webinar, it's hard to have the interaction with the audience. And I do want to make sure that I appeal to your intellectual level as we work on the problems. So these problems may be a little more sophisticated, but they'll identify and model what we plan to do with the students. So here's an example that I want you to think about. And I call this one Seeing Green. It's a simple kind of real-life problem. If you owned your own business, you'd have to know how much food to buy in order to serve your customers. In this example, we see that each meal at the Roadhouse Diner is served with a half cup of green beans. If there are 3 cups of green beans in a pound, how many meals could be served using 7 pounds of beans? Think for a minute. How would you solve this problem? What model or models would you use to demonstrate how your solution is correct? Or what would you use to explain to someone else how you solved the problem? Now, in the webinar, one way that students could model would be to make a drawing of what they know and what they're looking for. This could include pictures or lists to help them keep track of what they know and what they're looking for as they reread the problem. One way students might model this problem is, well, to make a drawing, to use a small cup to represent their half cup serving that's given per meal for green beans. They may use 3 large cups to show how many cups there are in 1 pound of beans. And they may draw the 7 piles of beans to represent 7 pounds. The use of drawings is one way of modeling how to solve the problem, or how to set up the problem. From there, students may actually then begin to think about, well, how do I divide out those 7 pounds of green beans into the cups that we have, the 3 cups? And so they may literally count out and begin to break out the number of green beans that are found in each pound. And so as you can see, we can count the number of cups to see how many green beans there are. Now, students may do the drawing in their head, and begin with the computational algorithm, which is fine, as long as they understand what each of the values represents. And so as they begin to work through the problem, it is suggested that they make use of labels to their numbers. So as they progress through the problem, they can recall what the numbers represent. This helps them when they have to defend their solution or to describe the process they went through to solve the problem to someone else. So for instance, they may have the 3 cups per pound times the 7 pounds creates 21 cups altogether. And as we know, the 21 cups times the 1/2 cup serving is then approximately 42 servings. Now, in many cases, I think students stumble here because they think faster than their hands can write, and it's important for them to get in the practice of knowing what the variables are, which is why writing the terms or the labels to the numbers is important as they make use of the models. Perhaps you came up with another way to solve. Did you add a drawing, or did you begin in a different place? What images did you create in your mind to solve the problem? Now, maybe you started with having 2 servings equal 1 cup of green beans. And if there were 3 cups to the pound, perhaps you drew 3 sets of 2 cups to show that you had 2 servings times the 3 cups that equaled the 6 servings of green beans. And then from that, if you had 7 pounds of those, you could draw out 7 groups of 6 servings, circle them as the model, number them to identify the quantity, and then at last come to the solution. The idea here is that the drawings become the model through which I can describe how I've solved the problem, that the picture, the sketch, becomes my way of solving the problem. This is what it means when we talk about modeling in mathematics, that modeling is more than just using manipulatives to develop concepts, because in that way they're used as tools. The modeling can be used as a way of showing what we know or demonstrating to someone else what our thinking process is. So let's look at that standard now in the elementary classroom. When working with problems, it is important that students discuss what is known and what it is that they are looking for. Do they understand what the missing piece is, what may be referred to as the variable? And for the lower elementary grades, this will be the first exposure to the concept of variable. And while it may not be the word that we use, they understand that it is something that is missing or needed to make the situation correct. Do we demonstrate our thinking by using the model? And how does the model help us to find or to describe the solution? We begin to see that proficient students will begin to create their own models, both graphically and algebraically, in order to solve a problem. And we want to encourage students to make that connection between the graphic symbol and the algebraic representation. I would encourage students to see the connection between their models and the real world and ask them to describe in their own words how they use the model to solve the problem. As you discuss the problem, identify some real-world issues that may affect the solution. And once the problem has been solved, ask the students to consider the answer within the context of the problem. For example, how would you create the meal or buy the food in order to serve a certain number of family members? How much food would you need if each person got a certain amount? Again, having the students model out the problem. And as they are working, it is important for them to reflect on, as they're working through it, does this make sense? These kinds of questions are the habits that teachers build in their students as they work through the problem-solving process in developing models of mathematics. By asking the questions of what do we know, what are we thinking, does the answer make sense, helps students to begin to develop the idea of the habit of mind that's important as part of the mathematical practice standards. And then finally, we want them to analyze that strategy to see if it makes sense, but also, is there a better way or another way to solve the problem? And throughout the exercise, it's important that students use the correct mathematical vocabulary as a way of identifying the words and the understanding that is tied to the terms. And this helps them to navigate the landscape that will prepare them for the future assessments. I'm going to show a little video clip at the moment of what's going on in a first grade classroom. And what I'd like you to do is to think about how the teacher is using modeling. Now, this video clip occurs after the students have had the use of the manipulatives as a tool to develop the concept of addition. Well, what I'd like you to do is to see how the teacher uses modeling as a way of helping them to connect the concrete experience that they've had with the pictorial representation they see on the student page. Ask yourself as you're looking at it, how does the teacher demonstrate modeling? And then what questions did the teacher ask to get the students to model? And then for yourself, reflect on how would this kind of instruction change the way your students might be engaged in the lesson. So let's look for a minute at this clip here of modeling with mathematics from a grade 1 classroom.
Math coach and author Robin Silby discusses the use of modeling in elementary grades. Let's watch as this first grade class models with mathematics.
We're going to work on this side together. At the top it says see and show. It says you can count back to subtract. Start with 6. So let's use 6 cubes. Let's use 6 reds. So now I have 6, and I want to count back 2. So we're going to take 2 away. Ready? 5, 4. So if I start with 6, and I take those 2 away, I start with 6, 5, 4. Now I have 4. Left. 6 minus 2 is 4. I'm counting back. So now let's look at number 1. Number 1 tells me to start with 8. So 8 cubes. Now we're going to count back. How many do they want us to take away for number 1? Look at number 1. Haley? We're going to take away 3. So when we have our 8, we're going to count back each time and count back. Ready? Start with 8. We're taking 3 away. So it's 8, 7, 6, 5. Good. Let's write it down on our paper. We started with 8, and we're writing 7, 6, 5. Took those away. So 8 minus 3 equals 5. Very good.
All right, so as you saw, the teacher began to demonstrate the modeling. She used the device, the Elmo, as a way of showing students, making the connection between the manipulative use that they had at the concrete level with the pictorial representation that was represented on the page. And she provided a clear example of how the model would work, making the connection between what was shown on the page and what the students were to do. And the question she asked the students to help get them to model was she had to ask the students to confirm their work as they were working through it. So think about yourself as the teacher, how you transition the way students think about the use of the manipulative from developing or exploring the concept on a concrete level to making the connection between the concrete and pictorial and using the manipulatives as a way of modeling the pictorial representation of the lesson. In the next examples, what I just want to talk about is that modeling. As you look at the standard mathematical practice number 4, that modeling with mathematics in the early grades may be as simple as making transitions from moving to connecting cubes to writing the numbers. Mathematically proficient students also make assumptions and approximations as they begin to model. They identify the important quantities and analyze the relationship between them. And finally, they begin to interpret their results and they reflect on, did this work make sense? Many times it's important, as in the modeling process, to stop and ask students, is there a way to improve? How else might I do this? Is there another way? So that they begin to develop a flexibility to their thinking of using more than one way to solve a problem. I'm going to move forward now and give another example on thinking of the use of models that you can reflect on where you're sitting in viewing the presentation. And here's a problem to think about. The local skateboard team picks its president in an interesting way. The 7 members sit around a table, and each member counts off 1 clockwise around the table until 10 is reached. That person then is eliminated. The count begins again with 1, and the process is repeated till only 1 person is left. So in which chair is the next president sitting if there are 7 members sitting around the table? What I'm going to do is ask you to think about in this poll for a minute, which tools would you use to help solve this problem? All right, would you use some sort of counter, a sketch or a drawing? Would you use a table or chart? Would you create a math equation? Or would you use a conference table and 7 friends to help you model how to solve this problem? Well, I see we have some people that have a sense of humor like I do. And as we work towards the result, I'll just share this with you. You can see about 46% of the people would draw a sketch or a drawing, and 32% of you would do the actual physical work of using the conference table and the 7 friends. All right. What I just want to do is model through that, thinking about the process for solving it. And again, using the model, drawing it out, making a sketch. Maybe we put arrows around the table to show the direction of counting. Maybe we begin to number which direction we start. Where do we begin might be a question you ask yourself. How do we know who is the president around this table? How would we know where we began? I selected the person with the full sheet of paper and the medals on his jacket as being the president, but it could have been any other of the members. As we work to solve the problem, how might that change our answer? So as we work around the table, you'll see that the numbers in large will count around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and whoops, there's our person who's removed. And then we start the process again, working around the table, counting through. So how does the process work? The model, the sketch, provides that direction for us. I'll give you one more as we work through. We'll start again, counting around the table, 5, 6, 7, 8, 9, 10, and then who's eliminated. So as we look around the table, who do you think will be eliminated next? How do you know? Well, there you go. Who's eliminated next? Count around the table. And so the model, the sketch, then becomes the opportunity for solving the problem. If you, just in case you need to know, the new president is standing there. My question, though, to you is, as we work through that model of using the sketch, is what would happen if one more member was added to the group, that there were 8 instead of 7, would that affect the result? Would the result be different if we started at a different place around the table? What would happen if there were 9 people, 10 people, 11 people? Is there some way to calculate how many or what seat it would be in each case? And so that we allow the student then to expand the possibility, again, using the model as the foundation for solving the problem. So let me just summarize for a minute as we look at this standard. What does it mean? Well, it means that the students should be able to analyze a practical, real-world situation and use the model to help explain it. The students should be able to create more than one model. The students also should be able to use their model to solve other problems. And that as they reflect on their model, they should look to see if it's efficient or should be tweaked and adjusted in order to conform to some new conditions. Which leads us then into, well, what's the difference between the model and the tool? And as we think of tools, what I want you to do is think of tools as being the thing or the device that helps us to solve the problem or helps us to understand the problem. That mathematically proficient students consider all variety of tools when solving a problem. They might be pencil and paper, they may be concrete models, they may be rulers, protractors, spreadsheets, computer programs, anything that can help them reach a solution to the situation. Proficient students also begin to recognize which tool works best for given situations, and they begin to make decisions as to which one are easier or more practical to use. They look at the limitation of what the tool can do, and then they begin to use these tools in new and different ways, exploring and deepening their understanding to the tool as they work through the process. So as we begin to work on helping students to choose tools strategically, what we need to do is think about how we introduce those tools to students and what those advantages offer. We want to be able to make sure that students are able to determine that strength and weakness of a tool, and that they consider when working with a tool which one is more effective. For instance, if we're counting large quantities of numbers, we certainly don't want to use counters as one way of representing number, that the quantity becomes too great and distracts us from the work that we're doing. A tool like base 10 blocks may be more efficient or effective when working with large numbers. And then lastly, tools can help us demonstrate that finding solutions are easier when using the appropriate tool. And so the tools that we consider in the lower elementary grades, maybe the counters, connecting cubes, colored tiles, or base 10 blocks. And they progress into protractors and rulers and calculators, or possibly other digital tools as we move up in the upper elementary grades. But in any case, we need to provide students with opportunity to experiment with those tools in order to experience their usefulness and their effectiveness in solving the problem. I'm going to show one more video clip quickly from a grade 1 classroom. What I'd like you to do is just look at the tool and see how students use the tool, not in a way that you might think, but in a bit of a different way. All right? And so as we look at this, consider how teachers and classmates help each other determine the use of the tool, and how using different tools could change the approach that students might have in solving a problem.
Now, let's watch as this first grade class uses a variety of tools.
So that was the big number, right? Yeah. So it's like 12. Yeah, because it's the same number. and 6 more blue ones. So add them all together, and then you have 12. Let's go. To make sure we're right. Yep. So, 6, 7, 8, 9, 10, 11, 12, 8.
So in this case, the students actually use the tools not to develop the problem or find the solution, but they use it as a means of checking their work as they've been working through addition facts. That the tool then becomes used as a way of helping them to understand or to confirm what their mental calculation had arrived at. Think of that again, that the tool is the device which helps the students to prove or to understand the mathematics, to solve the problem. Here in 4th grade,
upper elementary grades will begin to recognize tools that are appropriate for solving different kinds of mathematical problems. They will be able to select from pencil and paper, concrete models, measurement tools, calculators, or from appropriate and available digital resources. Coach and author Robin Spooby discusses the use of appropriate tools at the upper elementary level.
in this particular case, the students are going to actually use the sketch as the tool, the manipulatives combined with the modeling in order to solve the problem. And the teacher then helps confirm that by using the whiteboard as a way of organizing and pulling their thoughts together.
They have to break up the 20, so 5, 10, 15.
What is interesting, and I don't want some of you to have a heart attack that the children are writing on the desk, but the teacher uses the desk as a model, as a tool for recording the student work by using water-based markers, and then they use a whiteboard cloth to clear the desk. A great opportunity for them to show their work as they're doing it, and the teacher can see on the desk the work that's being done. So I'm going to give one more problem before we get ready to close. And again, I want you to think about not so much the work that you're doing, but the tool that you would use. And here's an example of a token approach that the local science center uses different color emission tokens each day. And that this month they're using red, blue, green, yellow, and orange in that order beginning on the first day of the month. Assuming the Science Center is open every day, what color token would you receive on the 19th day? And so what I want you to think of is what possible tools could students use to help solve this problem or use as the device that could help them solve the problem. And so what I'm going to do is open a poll for the last polling question. Whoops. I don't see that last question here. I'm sorry. But the question I would ask is to think about, well, what tools might they use? Would that tool be a calendar, a chart, a number line, numbers using multiples of 5, or the actual physical counters or tokens? That different tools allow you to think about what students do and how they think through solving the problem. So as you work with your students and think of the students, allow them the opportunity to have a variety of tools available and for use in solving the problem. Using a calendar is a very physical model of counting the days out. Using the tokens represents a very physical way of putting the colors in order and maybe putting the colors in order and then repeating and looking at the pattern. Number line is one way of counting. and the chart may be a way of organizing. So I just want to point out a few examples in McGraw-Hill My Math again that show different ways that we identify or provide for teachers an opportunity for making connections between the modeling of the mathematics and the use of the tool. That in some ways students could model this problem where Jerry has 2 colors of balloons. He has 19 balloons in all. What color balloon do we have? We look at the example that's provided. What are some of the ways that what tools might students use to solve the problem? Maybe they'll use a part-part whole chart. Maybe they'll use bar modeling as an example. Maybe they'll use actual color counters to model the different quantities and then count all together. But this example can incorporate both the modeling and the use of tools depending on the level of student understanding. As we move up the grade, you'll see that there's opportunities for drawing that allow students to connect the physical models of blocks with those of a drawing. And lastly, moving again from that physical representation to a pictorial representation, making the connection between physical manipulatives, the pictorial level, and then having the students create their own model in their own drawings. So in summary, I'd just like to conclude that as we reach the end of the workshop, to remember that it's teachers that we help to provide the culture and the environment in which our students build the confidence they need when they are allowed to select the tools that work best for them. And that as teachers we can help stretch students to build a stronger and broader repertoire of strategies and ideas through our own availability of different tools and models, but also through thinking aloud and direct modeling to help students make the connection. Remember that models are the methods that are used for solving the problems, while tools are the devices that they use to work with. That both tools and models represent creativity and require experimentation. That we don't always understand how to use them the first time, and that it takes practice over multiple experiences to become familiar with them. And that students who have access to a wide variety of tools on a daily basis are better apt to perform better and make connections in their mathematical development. And lastly, it's important to remember to model the approach. That students need to see how the teacher uses both the tools and explains the models as they're solving mathematical problems. So I thank you very much for the time this evening or this afternoon. I appreciate your sharing your time with us. Our next session is on November 20th. And if you'd like to see more information about our webinars, to visit mheonline.com/edx. Thank you. Ala, do you want to finish?
I do. Thank you, Michael, so much. Thank you, everyone, for joining us. As Michael said, our next webinar is on November 20th, and we're going to cover the communication skills of mathematics, which is mathematical practices 2 and 3. The other thing that I wanted to let you know, too, is that when you close out of your webinar, you're going to see a survey. We would really appreciate it if you would fill out that survey, because we appreciate the feedback, and anything that you can tell us to help us improve these sessions will be much appreciated. Also, you're going to receive a follow-up email that will let you know where to get all the handouts that are available for this session. These handouts include some PDFs of program pages from MyMath, as well as some of the activities that Michael went through with you. And you can also get the videos that we watched in